In this video, we're going to introduce heap device APIs. This is relative basic knowledge. We have never introduced it before, but before introducing multi-GPU programming, we need to learn how to query the number of devices and the device properties that is currently available on the platform. So, in this video, we're going to introduce heap device APIs. At high level, there are basically three APIs that we want to use. The first one is heap get device count, the second one is heap get device properties, and the third one is heap set device. So let's introduce these three APIs with an example. In this example, our goal is to find the most powerful GPU and use that particular GPU. So as you can see, we start with this main program. We define two variables. The first one is device count, and the second one is props. The props has the type of heap device properties, and the _t means it's a struct. We start to use this API called heap device count. We get the number of GPUs that are available by calling this API called heap get device count. We pass in the pointer to this device count so that this function can modify this variable. Of course, in rare cases, this function may return error. For example, if we do not have the privilege to use the GPUs or if ROCm is not properly installed, this function may return error. But for the purpose of simplicity, we do not really include a code for error handling. Next is the main part of the program that finds the GPU with the highest clock frequency. So we define two variables. One is the fastest GPU and one is the fastest GPU frequency. We set them to 0 because we want to search for the GPU with the highest frequency. We implement this part of code in a loop. This loop will iterate through all the devices using this device count number acquired from previous API. Now in the body of this loop, we first use this API called heap get device properties. We pass the pointer to the props so that this props field can be modified by this function. And we also need to specify I here because we want to specify which device we're getting the properties. So props is a struct, it contains many fields. We'll introduce it in the next slide. But here, we only use the field called clock rate, which is the core frequency that GPU runs at. Now we compare with the fastest GPU frequency. If this GPU has faster frequency than all the GPUs that we have tested, we set this particular GPU to be the fastest GPU. Then after this loop, we should already find the fastest GPU, and the fastest GPU ID is stored in this variable called fastest GPU. Other than printing the result, we can select the GPU to use. To select a particular GPU to use, we can call this function called heap set device fastest GPU. Once we call this API, all the following operations are based on this GPU. If we allocate the memory, we copy the data, we launch kernels, we create stream, all these operations are associated with this particular GPU. If you want to switch to another GPU, you simply call this heap set device again, then you will be able to use another GPU. So the GPU that is being used is a thread local variable. If you have multiple CPU threads, they do not interfere with each other. As we said, heap device property is a struct. It contains many fields so that we can query those properties of this GPU. For example, we have name. What is the name of this particular device? We have multiprocessor count, which will tell us how many compute units are there in this particular GPU. We have common properties such as L2 cache size, and the architecture name is multi-GPU board. Some particular GPU board may include 2 GPUs. And there are some specific properties that are related to AMD GPUs. For example, we have this property called GPU arc, which will return something like 803, 906, 908 as we have introduced in section 5. It will tell us which particular chip that the GPU equips. We can check if this particular GPU supports concurrent kernels. So far, you have seen how to use some very basic heap device APIs, and there are a few extra APIs that are not frequently used, and the audience should refer to the official documents for those APIs. Starting from the next video, we're going to give examples about how to program multiple GPUs.